What's up, mathematicians? Justin here, and this is kind of a bonus follow-up video to the last video. I decided I wanted to do just one more application, so more advanced trig application, and this will be one in which we look at how we can use trigonometry to calculate the width of a canyon or a river or some other geographic feature that would be difficult to get across. Okay, so here we have a picture of this gap here. This would be our canyon or river or whatever it is. Maybe it's a canyon with a river at the bottom of it. But anyway, the idea is you have one edge over here, and this is the side that you, the observer, are on. And then there is some object that's close to the edge on the other side. And we'll put in a tree as our object. Now, what you can do as the observer is take an angle measure between the second point, the other point of observation, and the object on the other side of the canyon. You can take that angle measure at one point, and then you can go to a second point and take the angle measure at that point, and you can find the distance between the 2 points. Let's go ahead and draw in these missing sides. So we're going to go ahead and say that this angle here was 40 degrees. And we'll go ahead and say that this angle here, the angle made between points A and the tree, was 35 degrees. Okay. So as you can see, again, this is not a right triangle. And you can set this up potentially to be a right triangle, but maybe there's like some big rocks here, or maybe the canyon sort of, I don't know, it moves in or out. Or maybe you just have a hard time getting that lined up. Maybe this is just like a lot of shrubs and such, and you just can't access that area. So we are going to go ahead and draw in this altitude right here. So what we're looking for is the distance across the canyon, and that distance would be at a right angle to this line right here, going to the object that you're using. So we're going to need to decide on some variables. Let's call this distance x. That's the thing we're trying to figure out, the distance across the canyon. Now we have these two sides, which we don't know either. We don't know the lengths of either of these from where we would have that right angle. So what we can do is we can put in another variable here. We could put in a third variable z here, but that would make it so that we wouldn't be able to really solve it. But because we know this whole distance is 340 and this is y, this distance right here is going to be 340 minus y. Okay, now we want to figure out how to relate these variables in a way that's going to help us solve the problem. So let's see, from the perspective of the 35 or 40, let's start with a 40-degree angle. Okay, so 40-degree angle, we have the opposite is x, and we have the adjacent is y, and then the hypotenuse is something we don't really care about. So once again, we see from the fact that we're using opposite and adjacent that we will be using the tangent ratio here. Now, when we look at the 35-degree angle, we see once again the opposite is x. So opposite x. Adjacent is going to be 340 minus y. And opposite and adjacent, well, we're going to use the tangent there as well. Let's set up these ratios. So first off, the tangent of 40 degrees is equal to the opposite length, so x over y. And let's go ahead and multiply both sides by y. And so we get y times the tangent of 40, y times the tangent of 40 degrees is equal to x. Okay, so over here we have that the tangent of the 35-degree angle is the opposite side. Okay, tangent 35 degrees is the opposite. X divided by the adjacent, 340 minus y. We'll multiply that by both sides as well. Keep in mind these are two separate equations. Okay, so 340 minus y. Those cancel out, and we multiply by 340 minus y. So multiply that both sides. Well, since these cancel out, I'm left with 340 minus y times tangent of 35 equals x. So, okay, that means that I can put 340 minus y times the tangent of 35 degrees here as well. So since this equals x and this equals x, well, these two things equal each other. So we say y times the tangent of 40 degrees equals 340 minus y times the tangent of 35 degrees. Let's go ahead and use the distributive property. And our next step is going to say y equals the tangent of 40 degrees is equal to 340 times the tangent of 35 degrees minus y times the tangent of 35 degrees. Okay, so we want to get the y's all together. So let's add y tangent 35 degrees to both sides. These cancel out, and I get that y tangent 40 degrees plus y tangent 35 degrees is equal to 340 times the tangent of 35 degrees. So let's factor the y on this side. So I factor the y out, and then inside the parentheses I'll have the tangent of 40 degrees plus the tangent of 35 degrees. 340 times tangent of 35 degrees. Now, by the way, you could go ahead and figure all these out. It might actually make your life a little bit easier. I guess I just sort of like keeping them as they are and plugging the whole thing in my calculator at the end. But you certainly, I mean, these are just going to be numbers, right? The tangent of 40 degrees, we could just look it up and say, oh, instead of writing that out, let's go ahead and just write 0.84. You know, that would actually be less writing. So you're welcome to do it that way as well. And now I'm going to divide both sides by this thing. Well, I don't feel like writing it all out. But anyway, those cancel out. I'll write it out over here. So the tangent of 40 degrees plus the tangent of 35 degrees. So that's what I divide both sides by. And now I have an expression here that I can just plug into my calculator right there. Let's plug that whole thing in. So I'm going to use parentheses, 340 tangent 35, end parentheses. Let me make sure it's multiplying just to make sure. All right, 340 times tangent of 35 divided by parentheses tangent of 40 plus the tangent of 35 degrees. That gives me 154.7 if I round. So 154.7 meters. All right, now again, this is not the answer. 154.7 is not the value of x, it's the value of y. So, but the advantage is Now I can say, well, instead of y here, I can put 154.7 meters. And then this ratio that I set up here, the tangent of 40 degrees, I can say x over this instead of x over y. So let's go ahead and do that. So the tangent of 40 degrees is equal to x over, instead of x over y, it's x over 154.7. 154.7. Now multiply both sides by 154.7. 154.7. And I get that x is equal to, let's go ahead and plug it in. So 154.7 times the tangent 40 degrees, and I get 129.8 rounded to the nearest tenth. So 129.8 meters. So that is the distance across the canyon or the river or whatever geographic barrier you're measuring. Okay, thanks for watching and hope to see you in the next video. Bye-bye.